Welcome to Space News from the Electric Universe, brought to you by the Thunderbolts project at thunderbolts.info. On this series, we have presented evidence for a dramatically new way of viewing all celestial bodies. In an electric universe, nowhere can one find a, quote, island in space. Across vast cosmic distances, electric currents flow through the conductive medium of plasma, electromagnetically pinching gas and dust to form stars and planets. In our last episode, we focused on the electrical circuitry in our own celestial neighborhood in the inner solar system, connecting the sun to all the planets, including the Earth. Today we shift our focus to the outer solar system, where the tremendous electrified environments of the gas giants Saturn and Jupiter are the 7th of 10 reasons why the universe is electric. Charged planets in the outer solar system. The NASA missions Juno and Cassini to Jupiter and Saturn, respectively, have provided data that could shake planetary science to its core. The discoveries dramatically highlight the failures of standard theory versus the successful predictions of the electric universe. We begin an exploration of the Juno discoveries, which, in the words of NASA investigators, have proved that scientists' fundamental ideas about the Jovian atmosphere were, quote, totally wrong. One of the greatest surprises the team first reported was that Jupiter's magnetic field, which was already thought to be tremendously powerful, is twice as strong as previously believed. The turbulent Jovian atmosphere has also proved, quote, mind-boggling, with rapidly changing cyclones at the planet's poles proving far more dramatic and, quote, weird than investigators had imagined. As Juno principal investigator Scott Bolton stated, "Had someone shown me a picture of the pole just 10 years ago, I never would have guessed it was Jupiter." Scientists' estimates of the planet's internal structure have proved equally troubling. Scott Bolton states in a January 10, 2018 article on space.com, "Our ideas were totally wrong about the interior structure, about the atmosphere, and even about the magnetosphere." The article continues, "Astronomers believe that Jupiter had either a very small and dense core, or perhaps no core at all. But data from Juno revealed that Jupiter has an enormous, quote, fuzzy core that might be partially dissolved." This discrepancy between scientists' expectations and the data suggests that there's a lot we still don't know about giant gas planets, Bolton explained. A critical clue to the missing theoretical foundations for investigators is found in the following statement from the Space.com report. "Strangely, auroras on Jupiter seem to be powered by a mysterious physical force that astronomers haven't been able to identify. According to the mathematical calculations, Jupiter's auroras should be about 10 to 30 times more energetic than Earth's. But Jupiter has seen auroras that are hundreds of times stronger for no apparent reason." Scientists had long proposed that a kind of localized charge separation produced Jupiter's X-ray auroras in the planet's interaction with so-called volcanic plumes from its moons. That perspective was summarized as follows by NASA investigator Randy Gladstone. "The volcanic moon Io spews oxygen and sulfur ions into Jupiter's spinning magnetic field. Somehow, these ions make their way to Jupiter's poles, where electric fields send them hurtling toward the planet below. Upon entering the atmosphere, their electrons are first stripped away by molecules they run into, but as they slow down, they start grabbing electrons back. The, quote, charge exchange reaction produces intense X-ray auroras." And here we see perhaps the fundamental source of countless surprises for space scientists at all scales throughout the cosmos: the belief that no celestial object can have a net electrical charge. But this antiquated perspective is now refuted. As reported in an October 2017 science blog by author Emily Underwood, entitled, "Can Large Electric Fields Power Jupiter's X-ray Auroras?" The data revealed particle signatures of parallel electrical fields over the poles of Jupiter that forced electrons near the poles upward, away from the planet, while protons and other ions moved downward into the atmosphere. This massive electric potential, upward of 1 million electron volts, provides a possible explanation of where the X-ray auroras get their energy, according to the authors. It's always been the electric universe position that the tremendously powerful Jovian auroras, the weird and turbulent polar storms, and the planet's tremendously powerful magnetic field are all ultimately induced by electrical Birkeland currents from the Sun, focused at the planet's poles. As noted many times on this series, in recent years, retired professor of electrical engineering Dr. Donald Scott has developed a mathematical modeling of the structure of a Birkeland current, identified visually as counter-rotating cylinders, clearly seen in the earthly auroras, and dramatically at the poles of both Saturn, and as seen on your screen, in the at least 15 counter-rotating cylinders at the North Pole of Jupiter. A law of physics consistently stated on this series is that electric currents, and only electric currents, produce magnetic fields. Neither the Earth's nor any planet's magnetic field is produced through an internal dynamo, and all of the Juno data clearly supports this claim. Mission scientists acknowledge that all of the models which imagined a dynamo deep within the planet have been refuted, as reported by newscientist.com. A shock is that Jupiter's huge magnetic field is even stronger and much more irregular than expected. The irregularity of the field so far is a sign that the dynamo driving it may originate higher up in Jupiter's interior, perhaps from a layer of metallic hydrogen. Scott Bolton stated, "I didn't expect all the theories to be wrong, but there's motion going on in the planet we did not anticipate. But the quote, wrongness of all the standard theoretical predictions has not forced investigators to consider what electric universe proponents have always argued, that the source of Jupiter's magnetic field does not come from inside the planet at all, but rather it is induced by Birkeland currents, whose signature is clearly seen at the planet's poles. It has also been the prediction of the electric universe that a far more immense electrical circuitry exists in the Jovian system, connecting the gas giant to its moons, than standard astronomy has ever envisioned. It's critical to note that according to recent scientific research by the Cassini mission at Saturn, the spacecraft's magnetometer had only been able to detect about 5% of the electric currents in the so-called plumes of the Saturnian moon Enceladus. According to data from Cassini's Langmuir probe, the electric currents may in fact exceed 10 million amps. Likewise, the electric current system at Jupiter is the real cause of the dramatic electrical discharges seen on the Jovian moon Io, which astronomers have long erroneously identified as, quote, volcanic plumes. But the notion that the so-called plumes are produced by cryovolcanism has been repeatedly refuted by discovery. One of the most surprising features of the so-called plumes was their filamentary structure. The official Wikipedia page on the Vashtar-Patera region on Io states that the more than 300-kilometer high, quote, plume displays, quote, an as-yet unexplained filamentary structure. But as we've outlined many times, this statement is factually incorrect. As early as 1979, the renowned astrophysicist Thomas Gold proposed that the so-called volcanism on Io is actually high-energy electrical discharge activity. 9 years later, plasma physicist Dr. Anthony Peratt and co-author Alex Dessler wrote in their scientific paper that the best analog for Io's so-called plumes is the plasma gun, a mechanism that produces the distinct filamentary structure that is never present in volcanic plumes. In 1996, prior to the arrival of the Galileo probe at Io, physicist Wal Thornhill made a series of predictions, including the so-called plumes would be found to move across the surface of the moon. The, quote, vents of the plumes would be vastly hotter than the expected temperatures of lava. And the plumes are in fact the jets of moving cathode arcs, eroding the periphery of the dark areas that planetary geologists had been calling lava lakes. According to Thornhill, these so-called lava lakes are the solid dark surface of Io beneath the, quote, snow that has been deposited by continuous discharge activity. Therefore, the, quote, lava lakes would not reveal the heat of a recent lava flow. All of these predictions received stunning confirmation. Io's, quote, volcanic hotspots were not only hotter than any lava on Earth, they were too hot to be measured by Galileo's instruments. Also as predicted by Thornhill, the discharging was focused on the edges of the so-called lava lakes, though the rest of these dark fields are comparatively cold. In fact, the expected volcanic vents were not found. Inspiring further astonishment, the, quote, volcanic plumes emit ultraviolet light, which is unthinkable under normal conditions of volcanic venting, but which of course is characteristic of an electric arc. Nevertheless, space scientists today still insist that Io is the most volcanically active body in the solar system. The cryovolcanism, or ice volcanoes that scientists envision, is produced by Jupiter, quote, gravitationally needing the moon to induce tidal heating, producing volcanic eruptions. However, in 2013, scientific reports revealed that Io's so-called volcanoes are in the, quote, wrong locations, according to the predictions of every existing tidal heating model. As noted in a 2013 Huffington Post report, Io's major volcanic activity is concentrated 30 to 60 degrees farther east than models of its internal heat profile predict, suggesting that the exotic volcanic Jupiter moon is even more mysterious than researchers had previously thought. As noted by the lead author of a scientific paper, Christopher Hamilton, the findings, quote, can't be reconciled with any existing solid body tidal heating model. As mentioned, the Saturnian moon Enceladus displays filamentary jets similar to the electrical discharges seen on Io. Planetary scientists interpret these explosive features at Enceladus' south pole as, quote, ice geysers and plumes produced by cryovolcanism. But it's critical to remember that before the Cassini team discovered the features more than a decade ago, scientists had expected the moon to be geologically dead, and the last place they expected such activity was the moon's south pole. As reported by Space.com, the finding flipped everything scientists knew about Enceladus on its head, because what should have been a dead moon appeared to be geologically active, and what was supposed to be the moon's coldest region turned out to be its warmest. As in the electrical circuitry of the Jovian system, where the electrical footprints of the moons have been seen in Jupiter's aurora, the electric currents connecting Saturn and Enceladus are now recognized by planetary scientists. And like the tidal heating models for Io, new discoveries have only proved increasingly problematic for the theory of so-called cryovolcanism on Enceladus. In 2016, scientists were amazed to discover that when jets of dust and water vapor explode into space, when Enceladus is at its furthest from Saturn, the amount of gas accompanying the outbursts is anomalously low. As summarized by Space.com, the researchers expected quite a lot more gas expelled at the far part of Enceladus' orbit to help explain the outpouring of dust, but they found the gas output had bumped up by just 20%, far less than expected. The team had focused on a specific collimated jet that was part of a large water plume. The leader of the study said of the findings, "We had thought the amount of water vapor in the overall plume across the whole south polar area was being strongly affected by tidal forces from Saturn. Instead, we find that the small-scale jets are what's changing. Hypothetical cryovolcanoes resulting from tidal forces are not necessary to explain the stupendous filamentary structures on Enceladus and Io. More than a sufficient basis exists to finally consider the electrical interpretation." As we focus our attention on the gas giant Saturn and the stunning data from NASA's Cassini mission, we again see numerous opportunities to test the predictions of the electric universe versus those of standard theory. In fact, for over a decade, data from the Cassini spacecraft has confirmed many of these predictions, all of which were completely unexpected in standard reasoning. In 2005, Walt Thornhill published his analysis of scientists' discovery of a, quote, warm polar vortex at Saturn's south pole. He also offered an explicit prediction. The electric universe also predicts, experimentum crucis, that both poles should be hot, not one hot and the other cold. In 2008, the Cassini spacecraft confirmed the astonishing prediction. Astonishing because the freezing cold North Pole had been deprived of sunlight for more than 12 years. The author of a paper on the discovery stated, "We didn't expect it to have a hot spot at the north." From the electrical perspective, it is not coincidental that the hotspot is located, quote, smack dab in the center of the North Polar Vortex. Like the planet Venus's polar vortexes, Saturn's North Polar hotspot, and the vortex structure in which it is located, is created by a flow of electric current along magnetic field lines to the pole. In fact, the Sun's electromagnetic relationship with Saturn is also a stunning recent revelation. In 2016, scientists reported their first ever observation of so-called magnetic ropes traversing the vast distance between the Sun and the gas giant. The lead author of a paper in the Geophysical Research Letters says of the finding, contrary to previous ideas about Saturn's magnetosphere being unlike its terrestrial counterpart, these findings reveal that Saturn at times behaves and interacts with the Sun in much the same way as Earth. But how can the fluid dynamics that NASA envisions explain, quote, rope-like structures that twist and change dynamically and extend the nearly 900 million miles from the Sun to Saturn? The so-called magnetic ropes are in fact twisted filamentary pathways traversed by electrically charged particles. Again, the signature of Birkeland currents, counter-rotating cylinders, are clearly seen here at the North Pole of Saturn. Like the Juno data from Jupiter, the Cassini mission must force a dramatic reconsideration of the real cause of Saturn's magnetic field. Again, the findings do not fit with the predictions based on the belief that the magnetic field is generated by an internal dynamo deep within the planet. A major surprise is that Saturn's magnetic field appears to have no discernible tilt. As reported by Imperial College London, based on data collected by Cassini's magnetometer instrument, Saturn's magnetic field appears to be surprisingly well aligned with the planet's rotation axis. Previously, mission scientists thought that 0.06 degrees would be the lower limit of tilt that could generate the observed magnetic field. However, the results show that the tilt may be much less than this. Scientists currently think that planetary magnetic fields require some degree of tilt in order to sustain currents flowing through the liquid metal deep inside the planets. With no tilt, the currents would eventually subside and the field would disappear. Professor Michelle Doherty stated, "The tilt seems to be much smaller than we had previously estimated and quite challenging to explain." Additionally, the Cassini mission provides the opportunity to test the electrical model of the Saturnian rings, whose earliest origins trace to the experimental work of Norwegian explorer and scientist Christian Birkeland. Well over a century ago, Birkeland's famous magnetized terrella simulated the earthly auroras, revolutionary research that standard astronomy largely dismissed until Birkeland was finally validated more than half a century after his death. The terrella experiments also produced intriguing rings, which led Birkeland to systematically simulate the rings of Saturn. He found that the rings could be easily reproduced simply by changing the polarity of the electrical discharge. And now, a Langmuir probe on board the Cassini spacecraft has made yet another unexpected discovery for mission scientists: a strong electrical-chemical coupling between Saturn's atmosphere and its rings. As described on SpaceDaily.com on December 12, 2017, the upper atmosphere of Saturn is charged and consists primarily of hydrogen and hydrogen ions. Strong variations in density indicate that the electrically charged part of Saturn's atmosphere, the so-called ionosphere, has a strong coupling to the visible rings that consist primarily of ice particles. The ice particles are also electrically charged. The principal investigator of the Langmuir probe data stated, "The first results are surprising. It is as though the small ice particles in the D ring suck up electrons from the ionosphere. As a result of the coupling, electrical flows of gas to and from the rings along the magnetic field of Saturn cause the greatest variations in density. Like Jupiter, the tremendously electrified Saturnian environment is undeniable." Many planetary scientists had long proposed that Saturn's rings are billions of years old, perhaps even forming with Saturn itself in the conjectured infancy of the solar system. But in August of this year, the Cassini team attempted to estimate the mass of the rings in order to guess the rings' age. The idea is that a great mass would be required for the rings to withstand erosion from collisions over time. However, as noted in a BBC report, it is looking like the opposite may actually be true, that their mass is less than previously estimated. If confirmed, it points to the rings being the remnants of some object that has broken apart around Saturn in the recent past. Cassini project scientist Linda Spilker stated, "If the rings are less massive, they won't have had the mass to survive the micrometeoroid bombardment that we estimate to have happened since the formation of the planet. So we're heading in the direction of the rings being perhaps 100 million years old or so, which is quite young compared to the age of the solar system. But the chief principles of the Thunderbolts project have offered a radically different recent history of Saturn and all of the solar system. A history that includes an understanding of the electrical nature of stars and the electrical expulsion and capture of planets and moons. In this thesis, it is not possible to calculate the density of celestial bodies by estimating their mass using Newton's law of gravity. In the electrical model of stars, one cannot classify stars and gas giant planets based on their calculated mass. Stars are an electrical discharge phenomenon, and their electrical environment determines their mass, appearance, and classification. Our chief principles have proposed the provocative hypothesis that in the relatively recent past, Saturn was an independent brown dwarf star with its own family of close-orbiting small planets, and with its ephemeral rings being recently ejected within the last tens of thousands of years. This thesis was summarized by Wal Thornhill as follows. As a small star approaching the Sun, Saturn flickered like a faulty electric light when the two stellar magnetospheres or plasma sheaths touched. Saturn's electrical power was usurped by the Sun, and its appearance changed dramatically. Such rapid variability in the appearance of stars is well documented. Before dimming forever, Saturn would have flared up to relieve the stresses caused by the sudden change in electrical environment. Saturn's present low internal electrical stress, as indicated by its low apparent mass, suggests ejection activity. But even so, the core of the electric star has not completely cooled. Saturn still radiates more than twice the heat it receives from the Sun. And we have a simple explanation for the origin of Saturn's mysterious, short-lived rings. Of course, neither recent solar system instability nor the electrical capture of celestial bodies are concepts that planetary scientists have ever entertained. But the failures of the standard model of our solar system's formation and history are dramatically underscored with countless discoveries of seemingly baffling exoplanetary systems. In fact, in recent years, astronomers have more and more routinely described our own solar system as exceptionally strange. Recently, this problem has been affirmed by an international team of scientists who have discovered that exoplanets that orbit the same parent stars are, quote, like peas in a pod. The research, published in the Astronomical Journal, focused on close to 1,000 planets in over 350 multi-planet systems. A Phys.org report summarizes the findings as follows. The team found two surprising patterns. They found that exoplanets tend to be the same sizes as their neighbors. If one planet is small, the next planet around that same star is very likely to be small as well. And if one planet is big, the next is likely to be big. They also found that planets orbiting the same star tend to have a regular orbital spacing. The lead author of the research stated, "The planets in the system tend to be the same size and regularly spaced, like peas in a pod. These patterns would not occur if the planet sizes or spacings were drawn at random." Of course, this is in stark contrast to our solar system, where the planets are, in the words of physicist Wal Thornhill, a quote, fruit salad. This discrepancy has led astronomers to increasingly entertain dramatic changes to our solar system since its formation. The Phys.org report states, "In our solar system, the inner planets have surprisingly large spacing and diverse sizes. Abundant evidence in the solar system suggests that Jupiter and Saturn disrupted our system's early structure, resulting in the four widely spaced terrestrial planets we have today. Yet institutional science remains unready to entertain a dramatic disruption of our solar system that occurred much more recently, perhaps even within human memory. But what basis remains for continued faith in the 4.5 billion-year-old story of our solar system's formation and evolution? A story that has led to endless surprises and intractable problems for planetary scientists. It is past time for scientists to wipe the proverbial drawing board clean, to allow discovery to illuminate an increasingly self-evident fact that our world, our solar system, and our universe is electric.